We're a software company, and we've been in business for about 25 years. Here in Austin, headquartered here in Austin. We got about 300,000 customers, and we provide observability and IT management software for IT companies.
Wow.
So I am a part of the platform engineering team. Been a part of that team for about a year, which means I've been part of ClickHouse for maybe about a year. So haven't got a lot of experience with it, but I can say that the platform is an overloaded term, an overused term, so I'm going to describe what that is. We're responsible for ingestion, all the data that comes into SolarWinds, our observability product, receive messages, transformation, all the queuing, as well as services for those endpoints, those ingress endpoints. All the ClickHouse writes we're responsible for. These are services that we write and we maintain, as well as all the ClickHouse queries. So all of our feature teams do not write directly to ClickHouse. They read from ClickHouse. They read from our service, which is called the ClickHouse query, or actually we call it the chainsaw. And we're also responsible for ClickHouse, schema management, all the management of the cluster, all the configuration settings, all profiles, and settings like that. And also support. We're second level support. We usually get involved in any of these services, any platform services that are under stress or we're seeing some alerts on. And about our data, we ingest telemetry. We monitor devices, applications, databases, and Kubernetes clusters, and many other things. But we get metrics, logs, and traces from these different sources. And it's real time. The access to the data is real time from our customers. And it's a multi-tenant application. We don't have different tenants for different clusters, and we don't shard by tenant or anything like that. So this is actually real time. We have to be very, very, very conscious on the data that's coming through very fast. And we ingest in one of our clusters around 3 million messages per second, around 550 megabytes on average, and bursts of a gigabyte. So I'm going to kind of describe a research project that I first got involved with this platform engineering team. What they wanted me to figure out was, can we improve the primary key for the to improve the time boundaries for the data that's being ingested. It's time series data, so we're very conscious on the time bounds. So being new to ClickHouse, I needed to understand how ClickHouse stores and manages the data. So we use a merge tree table engine, like is very common, and I needed to understand the physical layout of the data to really understand, what am I tuning? Because you can't really tune something you don't know the mechanics of. So the merge tree table engine is broken. We have broken into partitions, and each partition is broken into multiple parts. As data is ingested, we create new parts. Of course, the engine creates new parts, and then they're merged down into smaller parts. So, and I needed to understand how ClickHouse resolves queries. In order to understand how can I tune the primary key, what data do I need to understand to figure that out? And I'll go into that in the next slide. And what are the characteristics about the queries for the metrics? What are the frequent time range queries? So to understand which data I need to look at, I needed to understand that. And it turns out that most of our queries are for the latest 60 minutes worth of data. And we have both interactive users looking at the last 60 minutes and alert evaluations. So when an IT professional gets an alert, they're going to look at the data to see what metrics are causing that. Alerts are configured probably like you all probably have metrics for a given threshold for a window, time window. So the hot queries are in the last 60 minutes. So the other thing that I wanted to understand is how does ClickHouse index? And a lot of you probably understand this, but this is a breakdown of a part, and this is shamelessly copied from from ClickHouse documentation, you probably recognize it. ClickHouse stores indexes based on a sparse index. So that means not all rows are indexed, but multiple rows represent a single entry in the primary key. And those entries are called marks. And each mark represents a granule, okay? So, and that's where index granularity comes from. How many rows represent a single entry in the primary key? So that's interesting to know that how many rows are represented in each, when a primary key is found and a mark is used, how many rows are actually loaded. If you got 2 marks, you got, 2 times that amount of data being loaded. So understanding that was key to me kind of figuring out, is the primary key the problem, or is an option for me to tune or not? So primary key effectiveness. So the analysis that I came up with was the last 60 minutes worth of data is the hot query data. It's the latest data coming in. When you got the batches of data that are coming in those parts, there's not a lot of time in that 60 minutes for those parts to merge down. They will definitely, over time, merge down, and they do it very fast, but we actually insert data very, very fast. And the primary index. Our primary index is pretty high cardinality, so that doesn't lend itself necessarily to an improvement in that primary index, mainly because I've seen that the first 2 columns in the primary index are, the cardinality is pretty high, which is tenant and then a namespace, and then the index hour. So what that tells me is, in the latest data that we're looking at, the primary key improving that is probably not going to be very effective. So, and that's what I concluded here. I think it would have a little effect on the marks that were changes. So what I decided to do is do a test on reducing the index granularity. So what my plan is to use a materialized view on the metrics table coming in, mirror it to a new table. The only difference is the index granularity. And then use our ClickHouse query service, which is Chainsaw. Since all queries go through Chainsaw, to be able to alternate between those 2 tables, so that I get kind of an apples to apples comparison between the old metrics and the new metrics. The only thing that's different is the granularity, index granularity. And then measure. Make sure that I measure the query performance, the effects of background merges, and memory usage. What I came up with is a query, and I don't have the query here, but I have the result of the query. Our index granularity on the metrics table right now was 1024. So it's 8 times smaller than the default, which is 8192. So this, I don't know if that's, you can see that. This is a table on the existing query. This is, I don't know how many hours this was, but probably close to, half a day. These queries are it's sorted by query, and then over here on the time window, over here, the time window in minutes. And you can see 60 minutes is this is the top 6 entries, or the top 6 time windows in seconds, and managed to look at CPU seconds, average query time, the read parts, how many parts were read in these queries, read marks, the primary key marks, and the corresponding column marks, and the number of read rows. And then I contrasted that with a change in index granularity. It reduced it significantly to 32, which is 32 times smaller than the 1024 that we already had. Now, if you look at this, you'll see that the average query time went from, for the 5-minute window, went from 76 milliseconds, which is a dev environment, so it's not near our production environment. It's much faster. But if you look at the index granularity at 32, it dropped it significantly. and all the way down to it looks like there's a difference in the 60-minute range, but not a whole lot. But also, you look at the average red marks. So you look at the 1024 when you have 1,024 rows that were representing one mark versus 32, you see that over time, the number of marks red were significantly higher. However, if you look at the average red rows, you look at the index granularity of 1024, there's a lot more rows being read. And the average number of rows is significantly less in the 32 index granularity. That is very encouraging from my perspective. However, there were some observations that I had on the side effects. So there was an increase in merge time. The merge times were a lot higher. I wouldn't say a lot higher. I would say, closer to not even 50% higher, but close. And that's significant. So you're talking about more CPU, more memory, and you have the primary index file size. You go from 1024 to 32. You got 32 times more entries in the primary key. So you're going to grow that. You imagine if you have a 10 gigabyte primary key index cache in memory, and going to 32, you got 320 gig, which is not insignificant. And same thing with the columns mark size. Each column has a column mark that represents the primary keys mark to identify the offset in the binary file. And that also is increased. The default is 5 gig, and that's an LRU cache, so it's evicted. One other thing I'd like to mention here is that one other tuning thing we observed is the local file system reads. We had a situation where we're looking for an opportunity to tune file reads, and the default for file system read method is pread thread pool, which physical reads go through a thread pool, and this we found out that this negatively affected our queries or our environment because we have solid state drives and a lot of memory. So we set that to pread to bypass that. Thanks.
I'm just thinking, is it good idea to keep all tenant in one table or separate tenants table-wise? Keep a separate table for each tenant, considering if one table goes in read-only mode, impact of blast radius would be less. Did you think about?
We have a lot of tenants, so that would probably explode the number of tables that we'd use. And I don't think our tables would go into read-only mode in that reflection. So I don't think that's something that. Can you think of a reason why we'd want to have multiple tables for the way we do tenants?
Have you seen instances where they've gone into read-only mode?
Yeah, especially with the hardware issues. We see a lot of issues with whenever there is a hardware issue, the system was tossed, and then when it comes back, table gets into read-only mode. And if we have multi-tenancy sitting in a single table, it blast radius is very hard.
We've been operating it for about 7 years. We've never seen that yet.
You were lucky.
Sure.
Any other questions?
And you mentioned time bucket. What was that time bucket? 5 minutes, 10 minutes?
Right, those are time windows for queries. So for the last, for example, any query that is done on the metrics table, it's a time series, is done on a time bound window. And like, for example, if the user's looking at a screen that says, give me the last 60 minutes, that's the time window that it's searching for. And those were honestly less than the 5-minute windows, where we were essentially looking at alert evaluations. So customers will configure alerts where they'll say a metric over this threshold for this time window, and that time window is 5 minutes, 1 minute, stuff like that. So those are the big queries, those evaluations, which is most of our A lot of our value comes out of just, setting your alerts and walking away and just getting notified that things are going south.
Which index granularity size did you wind up going with?
Good question. We're staying with 1024. The impact of lowering it to at least what I did with 32 would explode our primary key and our caches significantly. As well as the one thing I didn't measure, which I would like to have, was the impact on inserts. Our bulk inserts would be probably significantly negatively impacted on that.
You showed those statistics. How did you gather those?
The statistic, those are, I'm sorry, those are from the query log.
The query history?
Yeah, so you'll get the OS, the OS information, the OS CPU utilization out of the profile events for CPU user and system microseconds, which I calculated. Also, the marks and the parts are the marks and the parts are also.
Memory usage as well.
Yes, yes.
As a follow-up to this question, should we run those queries, like as part of your benchmarking?
Did I rerun those queries?
Yeah, as part of benchmarking.
It was constantly running. It was constantly running, so I could rerun those queries anytime.
Like if the query was query within the query log, did you just use that as part of statistics, or did you rerun the query as well as part of it?
No, those queries are live queries. This was a live environment, our dev environment. So it mirrored our production environment. So the actual usage was very, very similar to our production environment. So those alerts and those users are our users, our internal users, but it's an actually monitoring the application. Yes.
Like you mentioned, period, in our environments, we do see, at least for one of the environments, we do see issues with the open files. Like,
Yeah.
ClickHouse documentation says 65,000 set open files. So
Right.
65,000. But when we were looking for ClickHouse user, I think it considers based on the threads. Like, since it is single first multi-threaded, for ClickHouse, in our environments, we are seeing millions of open files. I don't know whether it is RHL 9 issue or it's still trying to figure out what is the reason why.
So the thread pool was, we're talking about physical reads off to the OS, and the thread pool was the physical read thread pool, whereas it was trying to reduce the number of OS reads through a common thread pool to make sure that that you didn't have to open up so many files. We don't have that problem. We have solid state drives, and we also have a lot of OS page cache. So that going directly to the file system improved performance quite a bit, which was nice for those queries.
Is that a cloud server or on-prem?
These are all on-prem. Yeah, we manage our own ClickHouse open source server. We have probably I believe 8 clusters that we're managing in Kubernetes. So.
And do you share keeper across all clusters, or do you keep?
They're all separate. They're all separate accounts, separate AWS accounts or Azure accounts in each one of those.
Each cluster has its own keeper.
Yes, it has its own keeper. And we are in a sharded environment right now. In our production, we have, I believe, 12 shards, each with 3 replicas, so we're 36 nodes. In one of our production clusters, the one that I'm referencing.
Do you use any DR also? DR setup? Do you have any DR setup? DR?
Yes, we do. We do backups on a full backup every week, and then incrementals every day.
And do you have
And we exercise those too. We exercise those backups.
any replication for with other region, or it is single region?
The 3 replicas will be
Single region is what we have the clusters in, and all of the applications running in the same, the Kubernetes clusters running in the same region as the ClickHouse cluster.
Great.
Right. Oh, and one more thing.
Sorry. Well, did you try other, so you said 32, did you try other types of indexes?
No, that's great. That's a great question. The next thing that I would like to do is probably go down to 512 to see if that's, we'd have to do the measurement or measure the memory usage. But I don't think it'd have as much impact on inserts and merges as going down to 32. I just wanted to do something drastic just to see what the differences were, and I was really surprised at the metrics on the query times.
But the trade-off's not worth it with
But-
the increased cost.
Absolutely, that's exactly the point that I wanted to make. But with this, one other thing I wanted to mention is our platform engineering team is hiring. So we've got a good representation of SolarWinds here in case you want to talk.